Right, lesson 9, we're busy with third forms and with rationalizing the denominator. So when we're busy with these third forms, you don't have to rationalize this denominator from the start. So you're first going to simplify. In the simplification, how will you show me root 48? What is root 48?
4 root 3.
And how did you get 4 root 3?
Calculator.
How are you supposed to get it? Using those factors. And then you would have gotten, let's do it once. 2 goes 24, 2 goes 12, 2 goes 6, 2 goes 3, 3 goes 1. What does it mean? That root 48 is equal to 2 squared times 2 squared times 3. And if it's inside of a root and it's multiplication, you can do each of them separately. So the square root of square 2 is 2 and 2, and the root 3 stays inside. So that's why the answer is 4 root 3. That's what you're supposed to do. Did you get a mark for doing that? Calculator. So the rest is
4 root
2, and for 12,
3
2 root 3,
and 2 root 2.
and 2 root 2. What are we seeing for simplification?
We see it's
Things starting to look the same, but they're not the same. So I've got a common
factor.
out. And what's going to be left?
Root 3 minus 2.
Okay, now remember the purpose is I want to simplify. Okay, so then at the bottom, what do we do?
Common factor.
Common factor 2.
Root 3 minus 2.
And how does that help me?
Cross cancel.
Because now something can cancel out. The moment that you decide to factorize, because I never said factorize. Why did you factorize? Because that's the method that we simplify. That's how we simplify. So after factorization, if nothing cancelled out, I was wasting my time. Then there is no simplification possible. But now those two brackets cancel out, and 2 goes into 4.
Twice.
Is there another way you could have done it?
Yes.
How?
Like
I did it by taking out a common 2 on the
Good,
numerator.
that's what I'm looking for. At the top, if your purpose was, listen, this stuff must cancel out. If your purpose was that, and you left the bottom as 2 root 3 minus 2 root 2, and decided, well, at the top I can make it look like this one by just taking out a common,
factor.
what? Because if I take out a common 2, I've got exactly what's at the bottom. So that's my mission. That's not usually what we do, because when we factorize, we tend to always take out the highest common factor. But this is what should be in your mind now for simplification. So we have 2 as our answer. For rationalizing a denominator, you multiply by what? By the bottom? By 1, yes.
Root
7 plus 2. Because at the bottom, that's what it's all about. I need to simplify that will not have a root sign in it. So the two brackets must look the same except for the plus and the minus. That's when I will have no more roots. If I made it a minus, like we've had in an example, if I made it a minus, I'd still have roots, and then the purpose is gone. Mission not accomplished. But you can't just add anything to the original sum. You must time it with 1. That's why we time it with 7 in a root plus 2 over 7 in a root plus 2, which is 1. The purpose is I want the bottom not to have a root. And now the bottom will be a FOIL sum, but it's 7 times root 7 giving me 7. And then plus 2 times minus 2 giving me minus 4. Why didn't I do the middle term? If you know it's going to cancel out, you don't have to do it. If you've forgotten, but I don't think you could have forgotten, that's your purpose here. it'll be minus 2 root 7 and plus 2 root 7, and that does give me 0, and no more root, mission accomplished. The top has to still be timed, so it's going to be 4 root 7 plus 8, right? At the bottom we've got a 3. Can I simplify this further? If you want to factorize at the top, can you? Does it serve a purpose? If you take out a common 4 or a common 2 at the top, what is the purpose? Because nothing's going to cancel out with a 3 at the bottom. So leave it as it is. It's possible to factorize, we don't do it because it doesn't serve a purpose. Last one like that, I still have to multiply with
4 minus
1, which is then going to be a bracket that looks the same as that one. This one had a minus, so I timed with a bracket with a plus to get to that first and last FOIL sums that you don't have to do the inners and outers. Again, I want that FOIL sum that I don't have to do the inners and outers, otherwise I'll still have roots. Because if I time, I still get a root. But now they'll fall away. So I'm timing with 4 minus root 2 over 4 minus root 2, making it a legal mathematical process because I'm multiplying my original sum with 1. So I'm not changing it. So if I want to time a sum with 1,000, just divide it by 1,000. Then just please tell me what's your purpose. Because there has to be a purpose. But it's not wrong. If you time it and then divide it by the same thing, you left it the same. So hopefully what you're doing has a purpose. Timing with 1 to get to the bottom, that's not going to be a root anymore. So we have, let's start with the top. We will have 4 root 2 minus 2. Because root 2 times root 2 is 2. Bottom, 16, because 4 times 4 is 16. Root 2 times root 2 is? Minus 2. It's actually root 4, right? Then that becomes 2. And so the answer is 4 root 2 minus 2 over 14. That's it. Simplification possible? Yes. How? Only way is factorization. Well, no, that's not the only way. But if you do factorize and take out a common 2, will that serve a purpose, or am I wasting my time? Okay, because you can cancel out. So if I take out a 2, there's 2 root 2 left and minus 1 left. And then when they cross out, it's going to be 2 root 2 minus 1 over 7. And if you go to your calculator, the calculator will give you this answer as well. Alternative, because I said there was another method, is if you put them both on their own denominators. Because in this case, we've had other sums where I didn't do this because it didn't help me. But is this something that you were taught in grade 8? When you've got a 2 term over a 1 term, you can put them each over their own denominators. And what's going to happen? You're going to get to 2 root 2 over 7. And you're going to get to minus 1 over 7. Is that the same? Which one is more simplified? The one that's 1 term or the one that's still 2 terms? Okay, because if I say 2 fractions subtracted, you should do it. So this one should be written like that, but that's a finicky thing. If you left it like this, I would have given you all the marks because you did what I asked you to do. There's no more roots at the bottom. Right. Okay, so we come to exponential equations. We've done all the exponent laws, but all of them have to be applied now in solving equations. You guys remember that there are 2 things that teachers always say in a math paper. For this one, I will say, solve for x. The previous ones were all simplify, simplify, simplify. So in these questions where we solve for x, you now have to realize there are how many types of equations? Obviously this is exponential. What gives it away? The exponent is the x. Are you with me? And there's rules. The other equations that you've done from grade 8 are what? Linear equations. Nice and easy. The rules, get your math toolbox to you. The rules for linear equations, get the x alone. Whatever's been done with it, chuck it to the other side. legally. The second one you were taught in grade 9 was quadratic equations. What's the laws there? A whole bunch of tools. Get it equal to 0. Factorize. Then your answers can either, one of the factors be equal to 0. That's in a nutshell what they are. The laws of those two. So we've got linear, we've got quadratic, and then we've got exponential. What is the math law for exponential equations? If, yes, get it to the same base. If the bases are the same, then they don't fall away. Let's talk mathematical. Then what will you write? M is equal to N. What happened to that A? They didn't fall away over the cliff. I didn't divide by them. I made a logical deduction. Because whatever's standing there, it's exactly the same on the left and the right with the powers being the same bases. So that means the exponent must be the same for them to be equal to each other. So you're going to get to something like that, where I've got, for instance, 2 times 3 to the x equals 2 times 3 to the 4 plus x. What are you going to deduct? That the x is equal to the 4 plus x. Let's make it a square just to be interesting. But then that will be equal to, what did you do with those other things? You made a logical deduction. Because if everything looks the same, then those exponents should be equal. And then I'll have a quadratic equation, which I'm almost sure won't be able to factorize because I just thumb-sucked it and got it from there. Are you with me? So remember whenever I do that. But if there was something else there, everything falls flat. Very important. It must be 1 power equal to 1 power. For this rule, everything has got its rules. You know, the toolbox. For everything there's a rule. So for this to happen, it's only going to be 1 power on either side. So let's get cracking in a nice grade 9 example. What will we do to solve this x? Prime numbers, right? So the 4 will be 2 to the power of 2, which makes that 2x. If you need to first put it in a bracket, then time it out, that's fine, but you're going to get 1 mark for that. What about the 8? 2 to the power of 3. And therefore, what happened to those bases? I made a logical deduction. Let you know what's going on here. Don't shout, please. So x is equal to 3 over 2. Now that we're in equations, we can always test ourselves. We don't have time in a test for that, but we can always test ourselves by going back to the top and in your calculator punching in 4 to the exponent 3 over 2, and that'll give you 8, and then you know your answer is right. Are you with me? Something else I wanted to say. For a grade 11 child, I have to make sure that my test is not set up that might be 2 to the 2x and a 9. Where the 9 will become a, because you don't know how to do that yet. You need something else in grade 12, which is logarithms, and then you'll get to them. When you get to logs, there'll be a method. So for now, whenever I give you an exponential equation, you should know there should be this thing about bases becoming the same. All right. Let's go to the next one. Suggestions. Can I say 3 times 2?
3 times 2 to the power of 3.
Not everybody's convinced. Can I say 3 times 2?
No.
Definitely not. Because that is a power. Consisting of the 2 and the x together, it's like a marriage, and this is the outsider. It can't go in there. Right. So what can you do? Remember, focus. What's your mission? I want to solve for x. So I want to teach you this basic principle. If you see the sum like that, I've got a jolly good idea that this should end up into something like that. I just don't know what that must be yet. That's what I know I'm aiming towards. So to get there, this is my mission.
Can't you divide by 3?
Divide by the 3. And then?
That's right.
Like ma'am said, I can't give you a 9 there because it doesn't become 2 to the power. It's got to be 2 to the power something. And that is 2 to the power. And your answer is 3. And if you go back to the original sum, substitute it in, time it all out, it should be equal to the right hand side. Are you with me? How many marks are such a sum? 2, maybe 3. Right, now it gets more tricky because you're not in grade 9 and 10 anymore. This has to now be done. Is it one term on either side? Well, it's not one power yet, but is it one term on either side? Okay. But how am I going to get it to the same bases? Well, look at those bases and tell me what you think is going to happen. 9, 27, 3. It's all going to be 3 to the, I don't know what, equal to 3 to the, I don't know what, because I don't know if it's going to be x or 2x or what is it going to be. Are you with me?
Yes.
Aiming towards something I know is going to happen. So how do I do it? Prime numbers, which we've been doing. So then I can make the 9 a 3 squared. Can I pick it right a little bit there so that I don't have to write it again? And the 27 is 3 cubed. Happy on that? So that now I have 3 to the power of 2x minus 2 grand and 3 to the, and then that one's the same. Could I just add them already? Plus x plus 2, or if you don't want to do that, keep it separate first. Alternative. But the bases are the same. You just need to first go and say, add those exponents, but you don't really have to. Add those exponents, and then I'm going to deduct that the exponents are equal to each other. So it's going to be 2x minus 2 equal to 4x plus 2. Bring a little bit together. 4x plus 2. If you knew it over there and already dropped it and got to this immediately, is it fine? Okay, because there's certain things that you can omit. So we've got a what type of equation?
Linear.
Now, in a linear equation, what do? X is to one side, the other stuff to the other side. Which side do you want to go? I'll take it to the right because that's where the highest one is. It doesn't matter, alternative. So we got 4x minus 2x giving me 2x, and minus 2 minus 2 giving me minus 4. Then we get the x alone by dividing by 2, and the answer is negative 2, and I'm done. If you have time, which you do have when you're doing the homework, then you will go and substitute the x. Oh my goodness, look at the sum. So it's going to take you a while to substitute everything like that, but there's a negative 2. And then I don't know what the answer might be. It might be minus 15 or 72. If I do it on the right hand side and substitute all the x's with negative 2, that answer should also be 72 or whatever the answer is. Are you with me? If you want to simplify or test it. Alright, then we get to number 4. Obviously there's reasons for all the examples I give you because there's something different. What am I testing here? The surd. I'm testing whether you know what to do with this surd. What am I going to do with this surd? Okay, do you want to do prime factors first? I'm happy. Because I hope you're thinking 4, 8, exponential. We should be aiming for 2 to this power something. I'm not sure if it's going to be an x or a 2x or whatever. And 2 to the something. That's what I'm aiming for. So if you want to do that first, we're going to have 2 to the 2x in a square root. Can I not immediately then say, well, it's going to be 2x divided by 2 and it's just x? Just be careful you don't do too many steps in one and make mistakes. For this one, the 8 will become 2 to the power of 3, which will become, if I time out the exponents, 3x plus 1, but it's
3x plus 3.
Oh, thank you. At the bottom, which is a little bit of a problem. Sort it out now. This will then become 2 to the power of? What rule did you use? Exponent divided by root signs. Gives me just x. Because 2x divided by 2 is equal to 1x. What happens to this one? So the 8, because I'm seeing some frowns, is going to be 3x, 3 times x, and 3 times 1. And then now I need to get both bases the same. What's the problem here?
The 1.
It's divided, it's at the bottom.
So make all the exponents
So
minus.
take it to the top, because there's a rule. And if you take it to the top, the exponent will be negative 3x minus negative. If this was a minus, then it would have been a plus, because that's another exponent law. And eventually I'm where I wanted to be. I didn't know what those exponents were going to be, but I knew I was kind of like almost positive that the bases were going to be 2. So what do we do now? We make a
Linear equation.
logical deduction. And the equation jumping out from there is linear. Can it be quadratic? Yes. Then we take our rules for quadratic. Alright, so this is going to be 4x because I'm taking the 1x plus 3x to the left equal to negative 3. And then we divide by 4. I always like to keep it back to basics, grade 8 style. Whatever you do, to get the 3x away, you say plus 3x on the right, plus 3x on the left. To get the 4 away, you say divide by 4 and divide by 4, and the answer is negative 3 over 4. Are there different ways of writing fractions? There's decimals, there's improper fractions, like this one, for instance. If you wrote 1.5, is it fine? Yeah, if you wrote 1,5, is it fine? But please can I arrange with you that we all kind of like do the norm. And the norm is leave it in improper fraction. Okay, so this answer was negative 3 over 4. Don't write negative 0,75 for instance. So the question still says, what must you do? Solve for x, and we're seeing it's exponential, so I got a good idea I'm aiming for. 2 to the x equal 2 to the something. For grade 11 definitely, grade 12 it could be something else and you're using a different technique. For this one though, how can I use that law of mine that says get the two alone to each other if there are two terms? Because remember, you have to have 1 power equals 1 power. Yes, you have to factorize. There's a plus and a minus, so you've got to factorize, which means first type hopefully always is common factor. And it helps you to write it separately so that you can take out the common factor 2 to the x, and there's left 2 squared. Happy with me? Immediately writing the 4 because you're now going to be working with numbers. And then what's left in that one? Negative 1. My aim is what? I want this alone. So get rid of that bracket. You can first subtract to get 3 and then go and divide it. If you want to, you can even go say take that whole 12 and divide it by 4 minus 1. Keep the mission in mind. This is what I want alone. So I'll have 2 to the x times 3 equal to 12. To get that one alone, I have to, instead of timing with 3, divide by 3 and the answer is 4. And then I feel happy in my heart because I know these bases are the same, so that should be in my syllabus. And it's 2 to the x equals 2 to the 2, so x is equal to 2. Could I not have used k method? It wasn't necessary, but this one though, it wasn't that difficult. But if I did want to use k method, what would it have looked like?
2x equals k.
That would have been my k, right?
Yes, ma'am.
So you would have had k times 4
Yeah.
minus
K.
k equal to,
12.
and that's 4k, right?
Yes.
Minus 1k is, so k is
Yes.
2x.
4, and then k is 2 to the x, 4 is 2 to the 2, x is equal to 2. Maybe there's one step less, I don't know. But it wasn't really necessary to do it, but sometimes it's the only way to do it. So keep it in mind, it might pop up here. This is the way we're teaching you now. I'll show you some examples, then sometimes I throw you one that you've got to think outside the box. Because mathematics is not. You always do this sum like this. It's always going to vary depending on the sum. Right. Now there's something interesting I want to show you. It didn't happen here, but it might happen sometime in your life. And it would have happened already sometime maybe, and you just went over it and don't remember it anymore. If it happens, two things. If it happens in an equation that we were working here, and our answer worked out to Gone are the x's. How? It depends on the sum. If the x's disappear, and what I write there is nonsense. When can 0 be 3? Well, it seems like that our money, 3 rand's not worth much these days, but are you with me? That's nonsense. That's untrue. I'm asking you at the beginning to solve for x. The x is missing in the first place, and what's left there is nonsense. Untrue nonsense. What does it mean? It means that, first of all, when you're solving x, you're actually trying to go to graphs and finding x-intercepts. So those of you who don't like parabolas, hyperbolas, straight lines, that's math. Because all of these things work back to the graphs. If you're busy with a linear equation, you're busy with a straight line. Quadratic equation, you're busy with a parabola. Exponential equations, you're busy with exponential graphs. So if I'm asking you to solve x in an exponential graph, and this was your sketch, moved up a little bit the asymptote, if you can still remember way, way, way back, and you were trying to find the x-intercept, what would you have found? There isn't one. This is the type of sum I'm talking about. If you're trying to find the x, and what's there doesn't help, if there's nothing happening there, it's untrue. That means it doesn't cut the x-axis. For a parabola as well, the parabola can sit like that, not cutting the x-axis. Search for x-intercepts, you're going to find something that doesn't work. It doesn't mean the sum doesn't work. It doesn't mean the sum was something wrong with it. When something like this happens, 2 things I'm teaching you. So if this answer here is untrue, you're going to say there are no real solutions. Alright? The second thing that then can happen is if your x is missing, but what stands there is true without the x, because the x's fell away. That means you can go back into the original sum and put in x's place whatever you like, and it'll work because this will stay true. Doesn't matter what the top was. So that means you're going to write your answer for x can be anything, except of course if there was some sort of a restriction somewhere, then it can't be that restriction. So this is the 2 things I'm teaching you here. If ever it happens, and it happens like in a mathematical career, grade 11, 12, maybe 2 times a year, maybe, if at all. If your sum develops into something that's nonsense, then you'll say that there's no real solution. Okay? If your sum develops and the x's fall away, doesn't mean the sum is wrong. It means that you could place anything into that x at the top, and it will still come out to something that is true. If it was 5 equal to 5, it still comes back down to 0 equals 0, basically, if you wanted to take it to one side. But it's true, irrespective of what x is. So x can be anything, obviously, without the exclusions. All right. I didn't give you one like that, but it's for future reference. When it pops up, you must know this from now on, if that happens. So we are going to have some factorization. We are going to have some normal ones. Homework, exercise 7 and exercise 8. And there's one sum that I didn't find something in your textbook like that. Something with a third. So you must please write that down for me.